Alright, so in the previous video, we actually learned the technique for integration using substitution already. And then we already discussed example 19, part A. Alright, so for this video, we are going to discuss part B and C. Alright, so again, as what I mentioned before, when you want to apply the integration by using substitution in A level, generally you will see a very obvious hint in the question. That means that they will give you the substitution straight away. Okay, so once you see that they ask you to do all these substitution, that means you are going to use the integration using substitution. All right, then again, as what I mentioned before, for higher level maths, when you want to apply this method, they are not going to provide you any hint. All right, so A level consider as quite good because they will provide you the hint, the substitution itself, to make your life easier. Okay, so let's continue with the example 19 part B. Right, so why I want to make it as as the discussion in another video is because of this example 19 part B. It involved the substitution by using trigo. Alright, so I just want to tell you that for most of the case, not all cases, right? For most of the example, if you are having the substitution by using trigo, most of the time you actually need to draw the triangle to help you later to get the final answer. Okay, so that's why I put it in this another video because our discussion might be slightly longer. Right. Okay, so let us start. So again, for part number B, very obvious, you can see that they ask you to use this as a substitution. So our starting part will be what? We will start from the substitution that they give you. So we are having x equals to 2 sine u. Right, so we are having x equals to 2 sine u. So the very first step is always to find out the differentiation. So I'm having dx over du. Alright, so for this example, I'm going to do the differentiation with respect to u. So I'm having dx du. If you want to do the implicit differentiation with respect to x, also can, it's up to you. Alright, so dx du. So 2 is a constant, you just copy. When you want to differentiate sine u, you'll get a cos. So you're having cos u here. Okay, and therefore if I rephrase it again, then I'm having dx is equals to 2 cos u du. Alright, so once you settle with the differentiation for the substitution, then you start to substitute and you want to change all your expression, the expression in the question. So you see that all these are x, right? You are having x squared and dx. You want to change it, become everything in u before we can do the integration. Right, so we will start here. So you will see that I just copy integration, square root, 4 is a 4, then minus, what is your x here? So your x, very obvious, you can look at this equation, it is equals to 2 sine u. So you're having 4 minus 2 sine u, the whole thing squared. Then you have square root, and after that, you are having dx here. So what is equivalent to dx? So the differentiation part just now, you can see that the dx is equals to 2 cos u du. So you can put in here 2 cos u du. So this whole thing is actually your dx. Alright, so all the substitution, you can actually get it from all the steps that you did just now. Okay. Alright, so after that, you need to try to simplify your equation first, maybe, before you can continue with the integration. Alright, so if I multiply in, I put in the square into the bracket, I will have 4, 2 square is a 4, sine u square, you will have sine square u. Alright, and then the 2 cos u du, I just copy first. Alright. Okay, after that, I want to make this equation, the expression become slightly easier before I can integrate it. So after I look at it, I realize that I can take out the 4. If I factorize out the 4, then I'm having 1 minus sine square u. Okay, then 2 cos u du. Okay, if I continue further, square root 4 is 2, right? And then square root, I just keep it. 1 minus sine square u, I can rewrite it become cos square u. And then I'm having 2 cos u du. Okay, so for those who are not so sure how I substitute from here to here, I'm actually using the sine square x plus cos square x equals to 1 identity. Alright, so from here you can see very easily that 1 minus sine square is equals to cos square. Alright, so further simplify it. So square root cos square, you're having cos. Alright, so 2 cos u du. So this is what I have for now. Alright, and after that, if I continue further, then I will have 4 cos square u du. Alright, so this is what I have for now. And then if you compare the original equation and also the equation after the substitution, right, you realize that everything now become u. There's no more x. That means you can start to do the integration. But if you look at this expression also, he actually never learned how to integrate cos square u. There's no straightforward formula for you for the integration for cos square u, right? So you need to do something first before you can integrate cos square u again. Right, so we actually learned this equation before. I don't know whether you still remember it or not. Okay, so I will just show it to you here. I will rephrase it become 2 and then cos square u du. And I'm going to use identity in chapter 3, which is cos 2x. So previously we learned, right, cos 2x is equals to 2 cos square x minus 1. So I would like to apply this step here, and eventually my equation will become cos 2x plus 1. Oh, sorry, it should be cos 2u plus 1, not the 2x. Alright, so this is what apply from this step to this step. Okay, so what I need to do so is because of I know that I cannot straight away integrate cos square u, but I can integrate something with cos power 1u. So I apply the identity in chapter 3, okay, to make my equation become cos power 1. Then only I can continue with my integration. Okay, alright, so after this step, I can continue here. Alright, I'll continue here. Yeah. Alright, so how can I continue here? 2 is a constant, therefore I just copy it. Okay, so what will you get if you want to integrate cos 2u? So when you want to integrate cos, you will have sine. So you have sine 2u divided by 2. You need to differentiate the 2u, you get a 2, then you divide it by 2 and then plus 1. So when you have plus 1, integrate 1, get a u. And then you put a plus c here. So some students will ask me, can I put the plus c inside the 2, inside the bracket? Can also. Alright, but no matter how, it is just a constant, so it will be easier for me to make it as a whole constant. So usually I will put the plus c at the end, outside the constant, outside the 2. Alright, okay. Then if you continue from here, you will see that you have sine 2u plus 2u plus c. Okay, so you can see that the integration for this part, it will not be very, very complicated. Alright, because this equation cos 2u plus 1 is very simple. So after you do the integration, it will be also very simple. But now we have a problem. Because I told you that for substitution method, your final answer is in terms of u, but your original question is in terms of x. Therefore, you need to think a way to change back the u or the answer in u become x. So usually that is a problem for us. Okay, so you need to do something extra again. Alright, so from here again, we will want to go back to the substitution that they gave us before. Okay, so from here, if I rephrase this equation, you will see that I will get sine u is equals to x over 2. So from here, I will want to actually draw a right angle triangle with the angle u. And since they tell you that sine u is x over 2, which means the opposite is x, the hypotenuse is 2. And therefore, the adjacent will be square root 2 squared, which is 4 minus x squared. Alright, okay. Then from here, you can start to use the information in this triangle and substitute back to get the correct answer in terms of x. All right, so again, sine 2u. All right, so sine 2u, you are having the triangle with the angle u. There's no 2u here. Therefore, for the sine 2u, I will want to expand it by using the trigo, again, the identity of trigo, sine 2u. You can expand it become 2 sine u cos u. Okay, so again, this is the double angle formula for sine 2u. All right, then plus 2u plus c. Okay, so 2 is a constant, just copy. What is sine u? So sine u, you'll get x over 2. What is cos u? So square root 4 minus x squared divided by 2. Okay, then what is 2? 2 is a constant, you just copy lah. Then what is the u? So again, please look at this equation. If you want to get the u, you need to bring the sine over, right? When you want to take the sine over, it will become sine inverse x over 2 plus c. And again, if you try to simplify everything, then if you rephrase it, final answer should look something like this. 1 over 2 x square root 4 minus x squared plus 2 sine inverse x over 2 then plus c. So this is our final answer. Alright, so you can see that actually this kind of question, it is not, to me, it is not really hard. Just that you need to know a lot of small details, a lot of concepts that you learned before, and you need to apply it here. Okay, so if there's any part that you're not so sure, please make sure that you go and do some simple revision from the previous chapters. Alright, okay, so you can see that the whole process is almost the same like what I mentioned before in the previous video for substitution. So the first one is, from the substitution, you try to do the differentiation. The second step is you try to change your equation in terms of x, become everything in terms of u. Okay, or the variable that mentioned in the question itself. Okay, so after you change everything in terms of u already, there's no more variable in x, then only you start the integration. So of course, when you start the integration, you might use some technique that you learned before to do the integration. So here we use the identity for trigo because this whole question is about trigo. Alright, so after you do the integration, then the last step is your answer is in terms of u, right? You have to change it become in terms of x. So for the substitution that involve trigo, usually you will need to use the triangle to help you. So how to use a triangle is you need to refer back to the original substitution given in the question. You draw a triangle out, then from this triangle you get the value for sine u, cos u, and change it back, become everything in terms of x. Alright, so this is a whole process. So I hope that you can have a look, roughly have an idea how to do it correctly. Okay, so some students will say that, if let's say I didn't show you this one, you totally don't know how to do this. So of course, this is to introduce the flow for you. Alright, so if you want to very familiar with the flow, of course, you need to practice more. Okay, by yourself on all these details. Alright, so this one we have, for example, 19, right? 19b. Okay, so I hope that you have the idea here. You might need some time to copy it and try to understand it. And of course, you need to have some time to have a look for all these details, all the identity details here. Alright? Okay. So if no problem, then we will continue to part number C. Okay, so for part number C, it is still differentiation. It is still the integration using substitution, and the substitution here involves the trigo again. And then what I want to emphasize here is this one. This is the definite integral. Alright, and they want you to have the exact value for your final answer. Okay, so when you're having the definite integral for substitution method also, this value, you have to change it as well. Alright, so I think I already reminded you all in the notes before. Okay, so please wait for a while. Right, so here you see when dealing with definite integral, the limits also need to change. So this is a common mistake that students will do always in the exam. They forget to change the limit and end up their final answer is very weird or even it's a wrong one, of course. Right. Okay, so I will show you the detail how to change it. Again, same concept. First of all, you need to start from the substitution giving in the question itself. So I will start from here. X is equals to sine theta. So first step, I need to do the differentiation. So I'm going to do the dx over d theta. All right, so x over d theta, you'll get differentiate sign, you get a cos. So cos theta. So if I rephrase it again, I'm having dx is equals to cos theta d theta. Okay, so this is the first step that we always do, okay, in solving this kind of question. But because of this is the definite integral, right? So usually for me, I will try to change the value here as well. So this is in terms of theta, right? So that means this is theta. Okay, so this one is also the theta. So this question itself is you need to change all the theta become x. Okay, right? So when your theta is equals to pi over 6, what is your x? So you substitute it into the substitution here. X equals to sine theta, right? So that means x equals to sine pi over 6. So pi over 6 is 30 degrees. That means you have x equals to half. And then when your theta is equals to 0, what will happen to the x again? So the x will become sine 0. So I'm having 0 here. Okay, so this is what we mentioned just now. For the limits value, you have the limit as well before you do any integration. Alright, so now I proceed to the second step now. I want to do the integration for cos power 3 theta d theta, and then 0 and pi over 6. Okay, so before I substitute and change the whole equation become the x, I will have a look. Okay, how can I change it become everything in x? So maybe I will focus here first. Okay, so I realized that if I want to substitute dx into the equation, I need to have cos theta d theta. Alright, so in my expression here, I try to rephrase it like this. I'm having 4 cos power square theta multiplied with cos theta. So cos power 2 theta multiplied with cos theta, you get cos power 3, right? Okay, and then d theta. So why I need to rephrase it like this is because of I want to replace this one by dx later. Okay, so I hope that you can see, right? Okay, then now the next one. If you look at the cos square theta here, okay, and you compare it with the substitution that it gives us just now, to replace the theta into x, right, you must have sine theta, but too bad I'm having cos square theta here. So I will try to replace it so that I will have equation in terms of sine theta. So again, I will change become 1 minus sine square theta. Then multiply with cos theta, d theta. Alright, so what I need to do so is because of I can substitute sine square theta by x later. Okay? Alright, so seems that everything is done, everything is clear now, then I will try to put in all the substitution. When theta is pi over 6, you get half just now for the x, so this is half. Okay? When theta equals to 0, then your x is also equals to 0, so you substitute it with 0 here. 4 is a 4, you just copy. 1, just copy. Minus, you just copy sine square theta. So sine theta is x. So sine square theta, you are having x square here. Okay, then multiply with what? Cos theta d theta. If you look at this part, you will have cos theta, this theta equals to dx. So you're having dx here. Alright, so eventually you will see that your equation, again, for the integration become very, very simple. And then if you double check again for this part, everything is in terms of x already. There's no more variable in theta. Then you can start the integration. 4 is the constant. Usually I prefer to take it out. 1, when you want to integrate, you get an x. X squared, when you integrate, you have x power 3 divided by 3. This is a simple integration only. 1 over 2 divided by, 1 over 2 and 0. So the limit will be 1 over 2 and 0. All right, and then after that, I think you should know how to do it because substitution value here is very, very simple. Okay, you can straight away substitute the value into the equation and you try to rephrase it. If you didn't do any careless mistake, the value that you get should be 11/6. Okay, so this part is quite easy. I'll just leave it for you to complete it. So the final answer for this is 11/6. Alright, so the main idea for this kind of question is when you're having the definite integral and you want to use the substitution method, you must always remember to substitute the limit as well, to change the limit as well. Alright, and again, this is a common mistake that students will do most of the time. Okay, right. So if no problem, then in the next video we are going to discuss another example. Alright, so I will stop here for this video for now.